After almost 4 years of planning and half a year construction time, the world's first adaptive high-rise building, the D1244, has been completed. The building features actuators and sensors to react to external disturbances, as well as to put itself in a state of oscillation during experiments. Besides the usual participants in the planning phase, such as architects, structural engineers, or building services engineers, experts in the fields of system dynamics and mechanical engineering had to be involved from the beginning. These hydraulic cylinders were, for the first time, used outside the context of mechanical engineering and integrated into columns and bracings of a high-rise building. Design and construction of the actuator assemblies was a major mechanical engineering challenge. The 16 diagonal bracings include tension rods that can hold from 400 to 700 kilonewtons. These rods guide the force towards the hydraulic cylinder. The assembly is pre-stressed using castle nuts secured by a cotter pin. Due to the high dynamic loads during experiments, each welded joint had to be checked individually. The high-rise is fitted with 128 strain gauge sensors, which were installed in advance on the steel parts and are protected by individual housings. Calibration and recording of stationary measurement errors has been performed for all sensors. They will be used to precisely measure a change of state of the structure induced by external disturbances, such as wind forces. Based on mathematical models, an optimization placed all 24 actuators within the structure. 8 of the actuators are placed in an efficient and space-saving way inside the quadratic hollow profile of the columns. During assembly, the up to 500 kilogram heavy parts had to be aligned and joined with millimeter precision. This required the transfer of high accuracy, precision, and small tolerances from mechanical to civil engineering. Lastly, the hydraulic cylinders were integrated. They will be able to apply forces of up to 300 kilonewtons to the structure. Bolts of 80 millimeters in diameter connect the actuators to the rest of the structure without any backlash. An access tower has already been completed in the summer of 2020. It provides means for all necessary electric cables and hydraulic pipes, as well as other building services needed within the D1244. The access tower is based on a simple and modular steel framework and now offers the opportunity for quick upgrades with additional building services components, additional cables or pipes, and an elevator. The structure is 100% steel with a total weight of 42 tons. All ceilings and facades are wooden, lightweight structures. Using removable connections and omitting composite materials renders D1244 100% recyclable. All materials can be separated and returned to their technical or biological cycle. Additionally, a replacement of single components, such as columns or ceilings with different materials or technologies, is always possible during the ongoing research period. The D1244 is accessed from the access tower via a 3-meter outrigger bridge. To prevent collisions, a small sheet covering the gap between the towers can be pulled up during experiments. The initial facade system is composed of a membrane on a wooden frame. It primarily offers a lightweight weather protection. Bolts on the steel structure hold the facade in place. New and innovative adaptive facade concepts will be developed during the second funding period and gradually replace the initial shell. These new facades will be able to react on changing outside conditions. With its height of 36.5 meters and its 12 floors, D1244 is definitely a high-rise building. Due to the small base area, its slenderness ratio is 1:7, which is typical for high-rise buildings. Therefore, the transfer of all research results to large-scale buildings and skyscrapers is valid. Our ultimate goal is to reduce resource consumption and CO2 emissions in the construction industry by 50% using this technology of adaptive structures and adaptive facades. This will be an important step towards a more sustainable construction industry.